3D printing has been around for decades, but it's recently gained the most traction over the last 5 years. It is the process of making your own 3D objects out of your desired materials, usually plastics. The first step to starting a 3D print is making or designing a model. If your product is going to interface with existing objects, it's a good idea to use a ruler or pair of calipers to measure the dimensions you would like. These models are made in a 3D modeling software. The most common softwares are Onshape, SolidWorks, and Fusion 360. These are the same softwares used day-to-day by professionals around the world. There are also third-party websites devoted to the posting of free 3D models that others have designed that you can download and use with your 3D printer. The number one website for this is Thingiverse, which is owned by MakerBot, a 3D printer manufacturer. Once you have your 3D model, you must slice it. This is where a different software takes the 3D model and turns it into something the printer can understand. This is the program that tells the printer where to move and how much plastic to make your part. After this, you'll need to load up your filament of choice. There's lots of options, from hard plastics to squishy rubbers, or even carbon fiber infused filament. This gets loaded into your printer, usually on the side or back. Leveling the bed is extremely important. The slicing software and the printer are making their calculations based on the assumption of a level bed. If it's not level, it throws off the whole print. You usually level the print bed by thumb screws. After everything is ready to print, your 3D model is sent to the printer. The printer works by extruding hot plastic, so first it must heat up. Next, it purges the old plastic. This makes sure you're starting with fresh plastic. Next is the printing step. Here, the 3D printer goes around and constructs the model sent to it. This is done by slowly extruding the plastic, layer by layer, until it makes the desired object. The height of these layers can be adjusted. If a smaller layer height is used, it gives greater resolution to the 3D print. Everything will feel smoother, but it comes at the cost of time. As the layers get shorter, there becomes more of them, which makes more work. Once the 3D print is done, it's a good idea to let it cool down a little bit. This helps to prevent permanent warping. The parts are usually stuck down hard to the build plate, so when the time comes, carefully use a scraper. Another option to a scraper is a newer technology, flexible build plates. After the print is over, it's as simple as bending it and watching your parts unstick themselves. Once the parts are in your hand, you might notice that they're a bit sharp in areas, or just didn't come out quite like you thought. In that case, you can use files, sandpaper, clippers, or in this example, a hot metal pick to melt away what isn't desired. If desiring a smoother finish, maybe because a larger layer height was used, there's a chemical process that can be done. Acetone smoothing subjects the model to acetone vapors, which slightly dissolve the model's surface. 3D printing can be a fun hobby. There's always something around the house that can be fixed by a 3D print. For engineers, this too is priceless because it allows for rapid prototyping and the use of exact materials. I hope this helped to increase your knowledge of 3D printers.